Okay, let's continue with our topic 5, part 3. Okay, now I need you to pay attention here. All right, because part 3 is considered the most challenging part. Okay, so our objective is to use the first and second derivative test. So we are going to learn 2 derivative tests. Derivative test is actually a method. Okay, we call that a test. Okay, to test on the graph. So 2 methods here. One is called the first derivative test. First derivative test is one method. The second method is called second derivative test. Okay, to find the critical points. All right, now the critical points refer to the maximum point. All right, this point is the critical point or the minimum point. This point also we call that a critical point. Okay, so we use the first derivative test to test the critical point. Use the second derivative test to test the critical point. Okay, so this is our first objective. And the second objective is to apply the procedure. All right, apply a method, a procedure to find the maximum point and the minimum point, and to solve the problem from the management, life, and social science. So it means that the second part is we are going to apply the first derivative test or the second derivative test into the real life problem. Is that okay? All right, now let's see what is first derivative test and second derivative test. We are going to start with the problem solving here. Okay. Now, the problem solving, all right, so the cost function of a production X item is this. Okay, now let's say we have a problem. All right, the cost function is this. And the price per item is this. Now, we want to find how to get the maximum profit. Okay. Now, we are not finding the marginal profit, but we want to find what is the maximum profit. Okay, you know, if you do a business, one of the objective is to find the maximum profit, right? Okay, so how do we find the maximum profit when we have the cost function and the price function? All right, so from the price function, maybe we can get the revenue function as well. All right, but how do we find the maximum profit? So at the end of the section, this section, we are going to learn how to solve this. Okay. Okay, now before we learn, okay, we are going through this one. We are learning towards this one. So before that, we try to understand some concept here. Now, first, we want to understand what is increasing and decreasing function. Okay, now can you tell me, all right, from the graph here, okay, from what point to what point the graph is actually increasing?
A to B and C to D.
Okay, very good. A to B, the graph is increasing, and C to D, the graph is increasing. Okay, so now an interval means that what point to what point? Okay, so what is interval? The interval means right, from what point to what point? Yeah? Okay, now if let's say, all right, so the fx1 is less than fx2, right? We say this is y line easier. If y1 is less than y2, okay, let's say this point is x1, and this is y1. This point is x2, and this point is y2. Okay, now if y1 is less than y2, all right, when the x1 is less than x2, then we say, all right, now we say this point y2 is greater than y1. So we say the function is increasing. It's increasing. All right, within this interval. Okay, the x is between x1 and x2. So this is the interval. How do we write? We write that when the x is between x1 and x2, the graph is increasing. Okay, now another way to write is interval is we write as a point form, x1, x2. Okay, so we write like this. So, okay, and so C and D there, the point is increasing. Now, how about decreasing? The graph decreasing, all right, you can see the graph decrease, right? Okay, so when the graph decrease, all right, so going down, we say this is decreasing. So when the y1 is more than the y2, okay, so let's say this is y1 and this is y2. This is x1. This is x2. So this point x1, y1. This point x2, y2. When y1 is greater than y2, okay, this one is greater than this one. All right, and x2 is greater than x1. So we say the graph is decreasing. Okay, now this part is more mathematical, all right, but however, if you sketch the graph, all right, you will know, all right, the function is actually increasing or decreasing. Okay. Now, when the graph is increasing, what happened to the slope? Okay, the slope is positive. Okay, so when the graph is increasing, the slope is positive. And when the graph is decreasing, the slope is negative. Okay. Now, what about if this part, when the function is constant? Okay, we can see here increasing, increasing, increasing. At this part, at this point, the slope is like this, right? Constant. Then only it will actually decrease. So what is the slope when, okay, the slope is a constant slope. What do you say, students? Okay, the slope is 0. Okay. So therefore, okay, so thank you for your answer. Now only appeared, right? The slope is 0. Okay, so we can see here, right? The slope is increasing up to this point. The slope is 0. Then the slope become negative, negative, up to this point, 0, then positive. Okay, so we know that from positive to negative, all right, it will pass to, from positive to negative, it will actually go to 0. Okay, so from positive slope to negative slope, it will actually go through 0 here. The m is 0, the slope is 0. And from negative to positive also, all right, it will go through 0 as well. Okay, so this point, the slope is 0. Okay, so in this case, we say, right, this one, the differentiation, this is also the slope. Okay, remember we talked about this. The slope is actually dy dx. Now, when the slope is positive, more than 0, for this interval, right? This interval means that this is actually point from A to B. Okay, take note, this is not xy, this is interval AB. Okay, so the A is here, the B is here. So this is not the coordinate XY. This is interval A to B, right? A to B. All right, then fx is increasing on the interval. All right, so we say the function is increasing when the slope is positive. When the slope is negative, all right, so on this interval, then the function is decreasing. And when the slope is 0, all right, so it is a stationary point. Okay, all right, so now this is about increasing and decreasing function. Okay, now let's talk about critical point. Okay, so critical point, right, refer to this point. Okay, so, and also this point. So the critical point is the turning point, we say, right? When we have this point, the turning point. This point, the turning point. All right, turning point. All right, we call this critical point. All right, now there are a lot of names. All right, it can be called critical point, stationary point, or turning point. Okay, so when you hear these three names, critical point, stationary point, and turning point, they are actually referred to the same thing. Okay, any questions here? Okay. Right, now this point, right, is a maximum point. Okay, we call this a relative maximum. Why we call this a relative maximum? Because this is a maximum point between here. Okay, between this point and this point. Okay, now you can see here, this point is actually larger than this one, right? So we cannot say this is an absolute maximum, because we cannot say this point is an absolute maximum because we found some other point is actually greater than this. But this point is a local maximum, so we call that a relative maximum point. Okay, and also we also call this a relative minimum point. Okay, now when we have a graph like this, this point is called, this is a minimum point, but this minimum point is the point minimum within this curve only. Okay, within this curve, this is the minimum point. Therefore, we say it's a relative minimum. Now, however, the R here is the absolute maximum. Why? Because this point is the smallest value. It's the smallest value on the entire graph, on the whole graph. This point is the minimum point. Therefore, we call this absolute minimum. Okay. All right. Now, this point is a maximum point. All right. But however, this is not the maximum for the whole graph, for the entire graph. Therefore, we also call this a relative minimum. That's right, relative maximum. And this one is also relative maximum. So the same things goes here. The T is a relative minimum. Okay. So this slide here is to explain what is when we call a point relative minimum and when we call a point absolute minimum. Okay, absolute means that absolute, all right, you know the meaning, all right? It means that it's totally, all right, is actually the minimum for the entire graph, right? So same thing goes to maximum, right? When the point, all right, is not the maximum for the entire graph, we call that relative maximum. Okay, so this slide is about explaining what is a relative and an absolute. Okay. Now, in this example, we are going to explain how to find the coordinates for the maximum point and the minimum point. All right, so we find the critical point. Okay, so this is the function x squared minus 4x plus 5. Okay, now how to find the critical point? All right, the solution is here, but however, I'm going to discuss and write the solution here. Okay, now to find the maximum point and minimum point, so first we are going to differentiate. Okay, why? Because we know that this is our concept. We know that when the differentiation is 0, we have the maximum point, we have the critical point. Okay, we know that when the differentiation is 0, we have the critical point. So first we differentiate the function. So after we differentiate the function, what do we get? We get 2x minus 4, right? We have 2x minus 4. Okay, now to find the critical point, right, we have to let the, okay, so we write at the critical point, the dy dx is 0. Therefore, 2x minus 4 is 0. All right, and we get the x is 2. All right, so now we know that at this point, right, the slope is 0. Okay, we have this. Okay, so how to find the y? Substitute the x equals to 2 back to here. All right, so we can find the y. The y is 1. Okay, substitute x equals to 2 back to here. All right, and here, x is 2. So we can get the y is 1. Therefore, we have this point, right, 2, 1. Okay, now, any questions here?
No questions.
All right, okay, thank you. All right, so remember, so this is how we find the critical point, the turning point. We use this one. Let the dy dx be 0. Okay, now, how to determine the nature of a critical point? Okay, now, what is the nature? The nature means that whether the critical point is a maximum or minimum. Okay, now in the previous example, we learned how to find the critical point. But for this critical point, whether it is a maximum point or a minimum point, right, we cannot find here. We don't know. We cannot determine here. So in the next discussion, we are going to learn how to determine whether the critical point is a minimum point or is a maximum point. Okay, now let's observe these two concepts here. Okay, now if the slope is from positive, right, now if the slope from on the left hand side of the critical point, this is a critical point, on the left hand side, if the slope is positive, and on the right hand side, the slope is negative, we say from positive to negative, then, okay, what point is this point? The graph goes like this. What do you think? All right, the graph goes like this.
Point.
Yes, it will be a maximum point. Okay, so we call that this will be a relative maximum point because it's from positive all the way to negative. All right, now on the other hand, all right, if for a critical point, okay, so the left hand side we have negative slope, and the right hand side we have positive slope. So the graph goes like this: negative slope, then positive slope. So What point is this point? It's a relative minimum point. Now, is that okay? Okay, this method is called the first derivative test. All right, so this is the first derivative test. First, we find the critical point. Okay, we find the critical point. After that, we will try to test. We test the slope on the left-hand side of the critical point. And also, we try to test the slope on the right-hand side of this critical point. Okay. So if the slope is from positive to negative, then we say the point is a maximum point. Okay, so changing from positive to negative. Now on the other hand, if the slope is changing from negative to positive, okay, so then this will be a relative minimum point. Okay, now we have the third situation. All right, student, please pay attention here. Now, if the slope, all right, the sign of the slope does not change. For example, here, okay, we have this one. Okay, we have this point. This point. Suppose a graph like this and like this. This is still, the slope is 0. Now, however, all right, if we test the left-hand side of the critical point, the sign is negative. And on the right-hand side, the sign is also negative. Then this point is not a relative, it's not a critical point. Okay, this point is not a critical point. So it is neither maximum nor minimum. Okay, so right, when the sign does not change, right, when the sign does not change, so it is not a maximum point or a minimum point. Now the same thing goes like this. If we have something like this, all right, it's supposed to graph go down, but it doesn't, it goes up again. So the slope is from positive to positive again. Okay, so this point is not a critical point. Okay, any questions here? Do you have any questions?
No.
No. Okay, now. So we are going to use this example to discuss how we actually use the first derivative test to determine the point, whether it's a maximum point or a minimum point. Okay, so this is the function. Okay, this is the function. So to find the critical point for this function, or the stationary point for this function, first we differentiate. So when we differentiate here, we have 4 bring down times 3, 12x to the power minus 1, 3. And differentiate this one, 3 bring down times 4, 12, 3 minus 1, 2. Differentiate this one, 2 bring down times 12, 24, 2 minus 1, 1. And differentiate 5 is 0. Okay, so when we differentiate the function, we get this one. Okay, now at the critical point or the stationary point, we apply this one. Okay, very important, the dy dx is 0. So first we apply the dy dx is 0. And what is the differentiation? The differentiation is this. Therefore, we bring this one over here. All right, substitute inside and let this be 0. Okay, now after that, we have to factorize this. We solve this one. Factorize, we get 12x, x minus 2, and x plus 1. Okay, so now from here, what do we know? We know that the x is 0, or x minus 2 is 0, or x plus 1 is 0. Okay, so x is 0, x minus 2 is 0, or x plus 1 is 0. All right, so of course, if x minus 2 is 0, the x is 2. If the x is if the x minus 1 is 0, then the x is negative 1. So we have these 3 points. Okay, so these 3 points here, they are the critical points. Now, at the moment, okay, at this moment, we still don't know whether the point here, they are maximum, relative maximum point or minimum point. So we need to find the sign, right, on the left and on the right of these points. So we write the point here. So we have this point, negative 1, 0, and 2. So we write the points here. Now, so what do we do? Okay, we are going to test the slope, left and right. Okay, so first we test the slope on the left of negative 1. So, okay, we choose one point. This one you have to choose. Okay, choose one point. All right, so on the left of negative 1, so you can choose negative 2 or negative 3 or negative 4. It doesn't matter. So choose one point. Substitute this point into, okay, into here. Substitute this point here. So we have, all right, when the x is negative 2. So we have 12 negative 2 x to the power of 3. Negative 2 to the power of 3 minus 12 negative 2 squared minus 24 negative 2. Okay, substitute into the f prime. Then we get the slope is negative 96. Okay, now what can we say here? This is negative slope, right? So the slope is like this. Okay, the slope is like this, going down. Now at this point, all right, when the x is negative 1, we know this is a critical point, so the slope is 0. All right, the slope is 0. All right, now after that, we choose one point on the right-hand side. Choose one point. Again, we choose one point on the right-hand side. Okay, but take note, this when we choose this point, do not choose beyond 0. Okay, we must choose the point between negative 1 and 0. Okay, choose one point between negative 1 and 0. So we choose negative 0.5. Okay, you can choose negative 0.1 or negative 0.9. It doesn't matter. All right, choose any point between negative 1 and 0. Substitute this point into the f prime. All right, so then we can find the slope. So from here we can see the slope is positive. All right, so the slope is like this. Okay, now we pause for a moment. Okay, student, can you tell me for this point, x equals to negative 1. Okay, what is the nature? Is this a maximum point or a minimum point?
Minimum.
Okay, thank you. Right, yes, it's a minimum point. Right, because the slope go down, flat, go up. Okay, negative, positive. That's right, negative, 0, positive is the minimum point. Okay, so now using the same thing, now after that, at this point, when the x is 0, All right, so the x is 0 is a critical point. The slope is 0. Okay, the slope is 0, so it's a horizontal line. And now we take one point between here. Take one point, yeah? Between 0 and 2, take one point. So choose, right, any point. All right, choose a point easier to find. Easy to find, easy for us to find the slope. So we can choose x equals to 1. Substitute 1 into here. So we find the slope is negative 24. This is the slope. Negative 24, so the slope is negative. Okay. Then we know the nature of this one. What is the nature of the point x equals to 0? Positive or negative? Sorry, maximum or minimum? Maximum or minimum, students?
Maximum.
Maximum.
All right. Yes, thank you. All right. So finally, we do the same for this part. All right. When the x is 2, the slope is 0. Okay. So the slope is 0. And we choose one point greater than 2. So we choose x equals to 3. Substitute into the f prime to test, and so it's positive. All right, so we know that this point also a minimum point. All right. Okay, so now if we want to sketch the graph, we can actually find the y. Okay, so find the y for these 3 points. Okay, 0, 2, and negative 1. Find the y for these 3 points. Okay, how to find the y here? How to find the y here?
Times it to the original equation.
Okay, very good. All right, so we substitute this one into this equation. Then we can find the y. All right, substitute this point into the equation here to find the y. Okay, so substitute negative 1, we can find the y is 0. Substitute 0, we can find the y is also 0. Substitute x equals to 2, we can find the y is negative 27. Okay, so when we sketch the graph, so this is what happened when the x is negative 1, the y is 0. So we have this point. Okay, so when the x is 0, the y is also 0. So we have, okay, sorry, this one is a mistake. It's supposed to be 5. Okay, all right, so then the y is 5. We have a 0, 5 here. Okay, at this point. So when x is 2, the y is negative 27. We have this point here. Okay, so when we sketch a graph, right, the graph will always be like this. Okay, going down. This is a turning point, so it turn up, then turn down again, up to here, then it turn up again. So we call this a turning point. Okay, so the graph go down, turn. All right, turn up, turn again. All right, so we have the graph like this. Okay, so the first derivative test also enable us to actually sketch the graph.